Hi, everybody. So I'm Jerome Petazzoni. I worked at Docker, and I'm the person who did Docker in Docker to run Docker within Docker. And so I'm here to talk about Docker at Docker. So it's Docker at Docker, and since we also use Docker in Docker at Docker, I will talk about how we use Docker in Docker at Docker as well. Anyway, so I do many things at Docker, but lastly, mostly tech talks. Less cool hacks than before. I hope we can change that this year. And before doing Docker, I was doing .cloud, so running a PaaS, so running lots of containers, not 500 million containers. We didn't go that far, but still, we got some little bit of experience with that. I would dare say that our stack is a little bit less impressive than the one from RelateIQ, but still, I hope there can be some useful bits here in the talk. So today, I want to talk about what we run, where we run it, what we don't run, and most importantly, how we run it, how we build it, and how we deploy it, because I think that's the most interesting part for most of you. All right, so first, what do we run at Docker Inc? So we have the Docker Hub. So the high level, as you probably know, the Docker Hub is this collection of services that you can use to make Docker more useful. So it is the kind of GitHub for containers where you can store your containers, your container images. You can have automated build systems. You have a library of public images, and it's awesome. But on the low level, the Docker Hub is a Django app. So there is a Django front end, which we are moving to React to kind of optimize and make that snappier and everything. But it's Django, and we have a lot of background workers. So what we do is that we actually deploy the same code for the Django front ends and the Celery workers in the background, and we just have a switch so that the same image can flip its behavior between I'm going to start Gunicorn and serve HTTP requests, and I'm going to start the Celery worker and pull jobs from the queue and do the job, basically. This is to make sure that we have exactly the same code and that we don't have mismatches between the code that the front end is queuing to the workers and the code that actually gets executed by the workers. So the registry, that's another big component of the Docker Hub, so that the part that actually stores images, that the version 1 of the registry is a Python Flask application. It's pretty simple. I don't know why there is a link to UCARP in the middle here, sorry. That should be a link to the code of the registry. It's on the Docker GitHub organization under Docker registry. The registry v2 is written in Go instead of Python. So why do we have a v2? Why is it in Go? The short version is that the v1 of the registry grew kind of organically. It's like, okay, we need something so that people can move images around. We knew that we would need many things like support for multiple architectures, signature, all those things. But at some point, you have to decide between ship today or ship in 15 months. And so we wanted to ship today, so the v1 of the registry was not perfect. And the API, at some point, we reached kind of the maximum point of upgrades and tweaks in the API. So we say, okay, we need a v2 API where we can implement properly signature, when we can think about having multiple architectures and all those things. And by the way, we will make that a Go application because at least that way we kind of remove the likeliness that this will be a bottleneck when you pull your images. Preliminary reports seem to show that the v2 registry is snappier for varying definitions of snappy. Anyway, the Docker Hub is also the automated build system. So that's this nifty feature that lets you link a GitHub or Bitbucket repo with a Docker Hub repo, so that whenever you push some code to your GitHub or Bitbucket repository, automatically there will be a hook that will kind of kick the Docker Hub, and the Docker Hub will pick the latest version of your code, or at least what you just pushed. It will build it and push the results to the registry. The internal code name for that is Highland, from the Highland Park facility and blah, blah, blah. So now, where does all that stuff run? That's pretty much what we run. There is no other secret project somewhere, I swear. So where does that run? We have some physical machines on Rackspace. So that's where we run the Docker Hub and the registry except for the storage bits, if I dare say. So why do we run on physical machines? Isn't that so like the 90s? So the reason is that when we started to do that, running containers on EC2 was complicated. We know because we've been doing that for 5 years at .cloud, and I don't have white hair, but that's probably because of some genetical alteration, because honestly, after running containers on EC2 for 5 years, I thought that I would kill myself at least a few hundred times. So we wanted to have physical machines so that when your kernel crashes and burns, you can figure out, okay, what happened? I just want a effing kernel stack trace. I want to know what was wrong. I want that stuff. You can't get that on EC2. And so doing that on physical machines allowed us to have a little bit more flexibility. And there were many bugs that took on average 18 months to fix on EC2, and that took us maybe 18 days instead on physical machines. So that was useful. That doesn't mean that we will stay on physical machines forever, but it was a really useful enabler. Then storage. We use S3 because it just works. It's pretty expensive, but it works. I mean, it's expensive when you have hundreds and hundreds of terabytes of stuff. If you just have a few gigs, it's way easier to use S3 than to build your own. But the registry tends to grow a little bit big. For distribution, so not for storage, but just to get the bits to your machines, we use CloudFront. So that's the CDN that kind of comes with AWS and S3. Basically, what we do is that when you pull an image, it will come from CloudFront. When you push, it will go through the Flask, or for the V2, the Golang registry app. But when you pull, everything will come from the CDN directly. There is no like bouncing through the app or something like that. So then for the automated build system, that runs on a bunch of Linode machines. So why? Well, because it's cheap, it's more elastic than physical machines, obviously, and also it's a kind of matter of choice, and I want to talk about that a little bit. We believe in choice in the sense that we want each team to be able to pick the right tools for the right job. If tomorrow we say, okay, we need to build a new feature in Docker so that your coffee machine can become self-aware and do stuff, that team will be able to pick whatever they want to that job. They won't have to use Rackspace physical machines and Linode things if they think that it's not okay. Now, this doesn't mean that every person at Docker Inc. can pick the latest technology fad that they think is fancy. It's a team consensus, so within a team you still have to convince the other engineers that you're working with that you really should use that. So it's a kind of balance between everybody has to use Java and Oracle, and oh yeah, I will use that latest framework because it looks really nice, and there are 2 people working on it, but that's probably more than enough to ensure stability and consistency and everything. So it's something in between, and so far it worked pretty well. Anyway, so back on topic. Now what we don't run, so there is a bunch of stuff that are hosted by third parties. So Elasticsearch for when you search for images on the Docker Hub, that's at Found. Redis is on Redis Labs, so mainly for caching. We used to use Redis as the pub/sub queue between the Django frontends and the Celery backend workers, so we kind of maxed it out, but after kind of investigating that, most likely we did not max out Redis, because maxing out Redis for pub/sub would be pretty hardcore, but we probably maxed out the way the Celery code enqueues stuff to Redis. There is basically, we switched to RabbitMQ for queuing, and we suspect that the RabbitMQ driver in Celery is just better than the Redis one. Anyway, switching to RabbitMQ helped a lot here. I won't tell who is hosting RabbitMQ yet, because first, I don't know, I forgot to ask, and apparently it's a pretty recent switch. And last but not least, for classic SQL databases, we use Heroku Postgres, and we are extremely happy with all those guys. Okay, so that might ring a bell, because in not the fact that we're using Heroku Postgres or whatever, or third-party things, but the fact that we don't run those services. In the previous talk, we were told there was a big diagram showing here's the stuff that we run in Docker, and there is the stuff that we don't run in Docker, and I noticed that there were all the persistent data stores. That's pretty much the same thing here. All the stuff that actually stores data, be it like the images for the registry or the stuff in Redis, even if it's not exactly storage, Elasticsearch, our SQL database, that stuff is not in containers. I think it's not a coincidence because Docker still has to graduate a few dans on its black belts before being really able to handle persistent data storage nicely. So what do to handle persistent data? Well, either you do like us and you rely on third-party services, or maybe you can use Flocker. So no, that's just a kind of personal plug, but you probably got from the first talks that Flocker would be nice to handle stateful data, and preliminary testing shows that yes, indeed. That's just my personal opinion, not the one of the company, standard disclaimer, blah, 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 but still. So why don't we run those data stores ourselves? Well, because our value add is to build Docker and build the platform around it, not to run a database or a message queue or something like that. There are many people who can do that very well, and it doesn't make sense for us to have a 10 people ops team to do all those things. At some point, though, we want to be able to run those things maybe ourselves, maybe in Docker, to kind of show the world that, yeah, it's possible to run that inside of Docker, it's fine. And also, even if it's not your core business, when something becomes mission critical, like if when your database is down, then nothing works and you can't make the money go in because your customers can't pay you or whatever, then it becomes mission critical and maybe you should operate it yourself, or at least make sure that whoever is operating it as a like 5 nines uptimes or something like that. So at some point we might internalize those things, but for now we're pretty happy with what we have. All right, so now the most interesting parts. How do we build and deploy all that stuff? So the pipeline looks like this. All the code is on private GitHub repos, and for the simplest services we use automated builds. I mean, we made automated builds, so if we're not using them, that would probably be a pretty big problem. For more complicated things, however, we have a private build server, which is kind of our own private automated build system. And it works exactly the same way. We pull down the code, we build it, we push that to private repos on the Docker Hub, and then our deployment pipeline will pre-pull those images on the servers, but the last step, like actually running those images, happens manually. So first, the build process itself, so all this pipeline, we have teams using Fig, others using a tool that we deployed in-house called Stacker. So you might wonder, hey, why are you deploying, I mean, why are you using Stacker and not Fig? Well, it's just because we wrote Stacker before Fig was a thing, and Stacker has many shortcomings and whatever, but it works for us, so we are kind of slowly converging everything to Compose. So Compose being the new Fig, if you will. So that's also pretty interesting because some people might say, hey, you're not really dogfooding your own tools. What's wrong with that? Why are you not using Compose if you're telling everybody to use Compose? Well, we have a lot of existing stuff that was there before Fig even existed, before Compose obviously existed. And so we continue to use that, and we want to migrate to Compose only when we're sure that we have kind of one-to-one feature parity. So that's why. So why don't we use automated builds for some stuff? Why do we have our internal build server? That's because automated builds lack one critical feature, which is like automatic tagging. In the sense of today, if with automated builds, if you create a new tag or a new branch in your repo and you push that, nothing will happen. When you set up an automated build, you have to say which branch or which tag you want to build from, and the Docker Hub will only pick up that specific tag or branch. So what we want to have is something dynamic when you can say, okay, watch that GitHub repo, and whenever there is a new tag, XYZ, then make a Docker build, and the image should be named something : XYZ. So automatically, each time a new tag shows up on your repo, you would have a new tag in your Docker repo. So Ken, one of our engineering managers, really wants to get that done so that we can get rid of our internal hack around the automated build system, and also because apparently it's a pretty frequently asked feature. So I said that we do manual go to production. That's kind of creepy to do manual operations. So what does that mean? We do kind of blue-green deployment. So basically, you have a set of containers that are running, and when you want to deploy the new version, you just have to run a tiny little script that will bring up the new version of the containers in the new environment, and you run everything side by side. If you're not familiar with blue-green deployment, the idea is that you run new and old side by side, and ideally you start sending a little bit of traffic to the new version. You see how things go, you look at the metrics, the error rates, and if everything is nice and shiny, then you send more and more traffic until you are sending 100% of the traffic to the new version, and then you can get rid of the old version. If at any point something goes wrong, you can switch back immediately to the old version and restore the old behavior. So we kind of do that, but at this point, we didn't feel like the need for an actual slowly increase the amount of traffic and so on. So what we do is that we just have a very simple load balancer that sends to both stacks, and that works pretty well for us. And when we do a deploy, we check those error rates, the various tracebacks and all that stuff that comes up, and if everything seems fine, we just stop the old stack, and that's it. And the next time, we just invert green and blue. So little details about how we do that. So for load balancing, we use HAProxy because it works. A little detail is that HAProxy stays running all the time. We don't do any fancy party trick like, oh, I dynamically reconfigure HAProxy or anything like that, because we found out that it was not necessary and it was dangerous anyway. So we just leave it running. And basically, when we only have the blue stack running and the green stack is not here, HAProxy is smart enough to realize that the green stack is not running and it will not send traffic that way. For high availability, so what happens when one of those HAProxies blows up, we use UCARP. So it's something so that you can have an IP address kind of floating between multiple machines. And so you have a machine that actually has the IP address. And when the machine goes down, the others say, okay, I'm going to take over that IP address now and receive that traffic. And it gives you a kind of failover in a matter of seconds when the machine goes down. So that's for hardware failures. Interesting fact, both HAProxy and UCARP run in containers, so that's nice. Now, things that don't run in containers. LowLevel metrics, like stuff like collectd, Datadog, this doesn't run in containers yet, but that might change because Docker 1.5 has --PID host that lets a container see all the processes of the system. Docker 1.5 is out. That was yesterday, I think, but I won't talk about it because that's not today's topic. Sorry. So future, what's on the roadmap in like how we do Docker at Docker? We want to use Compose, obviously. What about Swarm? Not yet, because Swarm is not production ready, and we really advertise it like that. We say to people, don't use Swarm in production yet. Some people just don't care and use it in production anyway, but still. Machine, it's not relevant for us now, so we probably won't use it for now. We are doing experimentations with EC2 to see, okay, what if we have big bursts of traffic or whatever? So we are also kind of bringing up that whole stack using auto-scaling groups and all the EC2 Fandango. We don't know if we will or will not move the stuff over. It will really depend on the results of those experimentations. And also, we don't do continuous deployment yet, but we are kind of looking into that. It's just scary. That's all. If you have questions, I will be happy to answer them. And surprise, just like every company in this city, we are hiring infrastructure people, QA, get paid to actually break stuff, and people coding in Python and Go and blah, blah, blah. Thanks.